it angular velocity, or we can also call it as angular frequency. Just a little bit of difference. That angular velocity will be a vector quantity, and then angular frequency is just a scalar quantity with the same magnitude.
Sir, are rotational velocity and angular velocity the same?
Yeah, they are the same. Angular velocity and rotational velocity, they are the same.
Okay, sir.
So consider any circular object moving. Let's say you have an object moving in a circle. Suppose this is the object, and it moves, it revolves in the circle, it revolves, and along with it, it's traveling on this straight path. So if it travels on its straight path, let's say this is the point of contact which it bears. This is the first point of contact that it has with the surface T1. Now, if it rolls on this surface without slipping, suppose it rolls like this without slipping, so it goes like this, and in this way, when it completes one revolution, when the object will complete one revolution, so during that time, it would have traveled a distance equal to 2 pi r. Am I correct?
Yes, sir.
If Yeah, so if it has traveled a distance of 2 pi r, so here the distance 2 pi r would be this will be the distance traveled 2 pi r when it has completed one rotation. So we can write here during one rotation. During one rotation, we have distance, linear distance traveled as we'll have linear distance. So linear distance will be equal to 2 pi r, and its distance from the point P1 to P2, that is the linear distance. And during this, the angular displacement, if I find out, so what can you tell me the angular displacement that it has traveled? Angular displacement, that means how much angle has this point P1 traveled. So during its rotation, we find out that the circle completes one rotation. So during one rotation, the angular speed, just one thing. Okay, welcome, just one. See. So here the angular displacement would be equal to 2 pi if I'm having for one revolution. So for one revolution, the angular displacement would be equal to 2 pi radian. If I find this angle in degrees, so this angle would be equal to 360 degrees. And we know that 360 degree will be equal to 2 pi radian. So let us say it takes a time period t for making one revolution. So I can find out the linear velocity v as linear distance 2 pi r divided by t. Right? So I'll get linear distance as 2 pi r by t. And if I find out the angular velocity omega, so angular velocity omega will be given by angular displacement 2 pi. I have the angular displacement 2 pi divided by t. Got both the points? The angular velocity and the linear velocity.
Sir, what is T here? Time, sir.
T is the time period of revolution.
Okay, sir.
Time it takes to complete one revolution. So since it is making one revolution from this point P1 to P2, so T is the time that it takes to complete one revolution, and hence T will be the time that it takes to cover the distance 2 pi r. So I can write the linear velocity V will be equal to 2 pi r by T, and I can also write omega will be equal to 2 pi by T. So clearly from this formula I can get 2 pi by T multiply R, and 2 pi by T is omega. So hence I get the formula R omega. So V is equal to R omega. The linear velocity is related with the angular velocity with the formula V equals to R omega. Got it? In the same
Yes,
way, we can obtain it by some other method also. See? Like we know the formula of theta. We know that theta can be measured as length of arc by radius. This is how we measure the angular displacement. Angle theta in radian is measured as length of arc by radius. So we can consider here that let this be certain angle theta that it has revolved. So suppose it revolves through a certain angle theta. So during this revolution of theta, it has traveled a length of arc L, and this is your radius R. So theta is given by L by R by definition. So this is the definition of theta. We have studied the angular measurement, how to measure the angles in radian. The angle in radian is measured as theta equals to L by R, right? So we can write this as R times of theta will be equal to L. Got it? If I divide both sides, if I divide both sides by T, so I will get here R theta by T will be equal to L by T. Got it? So theta by T is the angular velocity and L by T is the linear velocity. How fast the arc is being traversed. So that is the linear velocity, and hence we obtain the relationship between them as R omega equals to V. Again, the same relationship that we obtained.
Yes, sir. Got it.
Okay. So got the relationship between linear velocity and angular velocity. Now we can also relate angular acceleration. So in the similar way, we can write down angular acceleration. Angular acceleration means the vehicle or the circle is not moving with a uniform velocity. It is accelerating. Like the speed of rotation can be increased, the speed of rotation can be decreased. Okay. So if you have an angular velocity acceleration, so here we talked of two accelerations. When an object is moving in a circle, so you have two types, actually three types of acceleration are there. So first we'll discuss of these two types, which we call as angular acceleration, and we have a centripetal acceleration. Okay. So we'll first discuss about the centripetal acceleration, and then we'll move towards the angular acceleration. So our centripetal acceleration, it exists or it is there whenever an object is moving in a circle. So you will find centripetal acceleration. You find centripetal acceleration whenever the object is moving in a circle. So whether it's moving with uniform speed, or that is we say uniform circular motion, if it is uniform circular motion or non-uniform circular motion. So in both the cases, you will be finding a centripetal acceleration. So centripetal acceleration is always required by an object to be moving when it's moving in a circle. Let's see. So we had discussed this in the last class that if an object is moving in a circle, even with a constant velocity, even with a constant speed, it cannot have a constant velocity because the direction of velocity always changes. So it cannot be moving with a constant velocity. Let's say it moves in a uniform velocity. So you have an object, and here let's say an object moves in a circular path. Let this be the circular path. And on this circular path, you have an object which is moving. Okay, so this is the object which is moving with uniform motion. So it has a uniform circular motion. That means its speed is constant. That means the magnitude of velocity will be a constant. Okay. So it has a uniform speed or constant speed. Now here we observe that at every point the speed of the object changes. Suppose it's at this point, so at this point you find the speed of the object to be along this direction. You find at this point. So when the object is at this point, you will find the direction of velocity to be something like this. So the direction of velocity is always tangential. It's always tangent to the path. So here, this is the direction of velocity. Here, this is the direction of velocity. And it has completed an angular displacement of theta. So we observe here that the velocity is not constant. Velocity is changing due to the change of direction. At every point, we find the direction is changing, and hence we say that the velocity is changing.
Yes, sir.
So at every point, we have velocity constant. That's the uniform. Uh, Magnitude of the velocity is constant. Okay, so here, if we observe the acceleration, so let's observe. Can we say that there is an acceleration since we are finding that there is a change of velocity? So can we say that there is an acceleration?
Yes, sir.
Yeah. So this acceleration, even if the object is moving in a uniform with a uniform speed, there is an acceleration, and we had discussed that this acceleration always act towards the center. Okay, so acceleration here, it always act towards the center. This we had shown with the help of the parallelogram law. Still, we can use the parallelogram law to find out or to check that the, okay, so uh, just 1 minute. So here we have this, just, okay, we had the acceleration, right? So if you want to find out acceleration, we know that acceleration is given by the formula equals v minus u over t. This is the formula by which we give the acceleration. So we know that this one is the final velocity, this one is the initial velocity. So if I want to find out the change of velocity, I need to use the parallelogram law. So let's copy them and try to find out the change of velocity. So let this one be our, so here I have taken this vector. Then this vector also I will be taking, but in opposite direction. Just 1 minute. Okay. So see, these are the vectors. I want to find out their resultants. Okay. So here I can show you that if you take, this is your minus u. See, u was pointing in this direction. This is the direction of u. So this is your minus u and this is your v. If you complete your parallelogram, So by completing the parallelogram, you will observe that it points towards the center. See, complete the parallelogram and you will observe that it points toward the center. So this diagonal, if I draw the diagonal here, so the diagonal points toward the center. See the direction of the diagonal that we are getting. The diagonal is still pointing towards the center. Yes, is the diagonal pointing towards the center? This one, if I bring it,
Yes, sir.
if I bring it here, so see it points toward the center, right? So we observe here that the change of velocity is always towards the center of the circle. Okay. So here we have obtained that there will be a centripetal acceleration every time whenever the object is moving in a circle, whether there is an angular acceleration or there isn't an angular acceleration, you will find that there is acceleration which is directed towards the center. Okay. And this acceleration is given as v minus u by t. So the value of this acceleration has been calculated again using the vectors. So as we had seen that we can find out the resultant of the vector. The resultant vector can be calculated. So here the resultant vector, that is our this one. The magnitude of this vector can be calculated, and this magnitude of the vector, that is acceleration, is given as v squared by r or r omega squared. So a centripetal or centripetal acceleration is given as r omega squared. Okay. Or we can also write, if you substitute the value of omega as, so we have seen that formula v equals r omega. So by using v by r as omega, we can substitute the value of omega here and obtain the centripetal acceleration as v squared by r. So there will be a centripetal acceleration always. Always there will be a centripetal acceleration if an object is moving in a circle. Right? Now, the different ways where we do not have the centripetal acceleration, we cannot have the centripetal accelerations, is if the object is not moving in a circle. If it's moving in a circle, so it has to have a centripetal acceleration, right? So here, okay. So, see here, we have obtained our acceleration. Now, if the motion is non-uniform, if the motion is non-uniform, or if it has an angular acceleration. So if you have an angular acceleration, so during angular acceleration means its angular velocity changes. So and if it is an angular acceleration means we can write the angular acceleration omega alpha to be omega minus omega naught by t. I hope we had discussed this in the kinematics of angular motion. When we were discussing about the kinematics of the rotational motion, so we had discussed that the angular acceleration, just like the linear acceleration, we have, in the case of linear acceleration, we have v minus u by t. So here for the angular acceleration, we have the formula omega minus omega naught by t, where omega is the final angular velocity, omega naught is the initial angular velocity, and t is the time. So you will have a angular acceleration, and hence the angular acceleration will be given by omega minus omega naught by t. And from here we had obtained all the kinematic equations of motion. Like we had obtained omega will be equal to omega naught plus alpha t. This was the first equation of motion. We had obtained theta equals to omega naught t plus 1 by 2 alpha t squared. Then we had obtained the third equation, which is 2 alpha theta is equal to omega squared minus omega naught squared. Do you remember these kinematic equations of motion which we had derived?
Yes, sir. We remember.
Yeah, yeah. So just a quick idea was given over here about the angular acceleration. Okay. So if an object has an angular acceleration, so apart from the centripetal acceleration, there will be a tangential acceleration also applied to it. And this angular acceleration will impart some linear acceleration also. So the linear acceleration, you'll observe here that the linear acceleration A would be given by r times alpha. So here A represents the linear acceleration. Linear acceleration will be given by r multiply alpha. That means you will find some increase in linear speed also. Okay. So this was all that we had done yesterday. Any doubts in this?
No, sir.
Okay. So here, so see, this was all. You can do certain questions. Okay. If you find out the centripetal acceleration, let us try to find out the centripetal acceleration for different objects just by applying the formula. So you have an object of mass. Okay. A stone of mass 50 gram revolves in a circle of radius 0.5 meter. Radius 0.5 meter. With a frequency of with a frequency of 20 revolutions per minute. Let's say 50 revolutions per minute. That would be 120 revolutions per minute. Find the centripetal acceleration of the stone. Okay, so can you find out? Just check it once. You are given the number of revolutions per minute. So the number of revolutions per minute is just called the frequency. Are you able to get this? Anyway, how to solve out? Okay, you are given here frequency. Let's try to resolve this. Frequency means number of revolutions per second, per minute. So here frequency F is given as 120 revolutions per minute. If I convert it to revolutions per second, so this would be 120 multiply 1 by 60, which will turn out to be 2 revolutions per second. Okay. So now the formula for omega, we want our omega. Omega is given as 2 pi by t, and we know 1 by t is frequency. So we know 2 pi multiply frequency would be equal to omega. Okay. So omega can be obtained here, 2 pi multiply with frequency, that's 2. You get your answer as 4 pi. Understood up to here? How we found out the angular velocity omega?
Yes, sir.
Okay. Now, can you find out the centripetal acceleration? Use the formula of centripetal acceleration. So, centripetal acceleration is given as r omega squared. So, the value of r is 0.5 multiply omega, which is 4 pi and it's squared. So, you have 0.5.
8 pi square, sir.
Yeah, not 8. Okay, you will have 0.5 multiply 16 and pi square. So 16 multiply 0.5 would be 8 pi squared. So
Yes.
8 pi squared is the centripetal acceleration. And then you can find out from here, after this, you can find out, uh, after the centripetal acceleration, you can find out, if you want to find out centripetal force. So that also can be find out by multiplying mass with acceleration. See? Force is given as mass times acceleration. So can you find out the centripetal acceleration? Centripetal force. Mass is given as 50 grams and
5
acceleration
into
we have
10 power
1
minus
gram.
2.
Yeah. Okay.
So 5 into 10 to the power minus 2 into 8 pi square, no, sir.
You will be getting this 0.5 multiply 16 pi squared multiply 0.05.
Yes, sir.
And this is your centripetal force. So this will be your answer.
Yes, sir.
You get here 8 multiply 5 is will be 0.4 pi square. I think that is the answer.
I need to check.
Yeah, you can check it. Okay. So bye all of you.
Bye, sir.
Bye.
Thank you
So
for
the last
teaching
class.
me, sir.
Okay, bye.